Hello out there, and welcome back to part 2 of my observer pattern video series. So in the previous part we discussed the UML diagram and saw various versions of it, and in this part we will do the implementation. And so we ended up with a UML diagram of what it could currently look like using the existing functionality that Java provides, and it would look something like this. Now the two blue classes here, they are existing already in Java. The property change listener interface exists and the property change support class exists. And I will define the property change subject myself and the concrete subject and listeners. So we're going to use the traffic light example, making this a traffic light, and we will create multiple cars with various implementation. So they will all follow this UML diagram, but the association here and how the interface and the concrete listener relate to each other can actually be implemented in various ways, and I want to show you so that you can, you have more options when you implement this in the future. So this is what we're doing. This is the starting point. So let's skip to the code. I have my IntelliJ open here. Now, the first thing that would be to define the interface. So I'm actually going to add another two methods here that we're going to use. It's another add listener and another remove listener. I'm overloading them so that the new two methods take an extra argument, and I have that here already. I have my property change subject interface. I have the two methods from the interface in the diagram, which just takes a property change listener, and I can remove one. And then the other two methods here, add property change listener, which takes a name. I might actually call this event name because that's what we're using, and similar for this one, the event name. So the idea is that the property change support here, it can fire events with a name, and we can subscribe to specific events. Instead of just listening for all events, I can actually subscribe to specific events. So we're going to use that at some point later on. So I have the four methods here, and if I want my traffic light to be a subject, then I will have to implement this interface and also implement the functionality that comes with it here. So let's go to the traffic light. I have stripped it down a bit. So this is the basic functionality. My lights can be green, yellow, red, and back to yellow, and then we start over: green, yellow, red, yellow, green, and so on. So this is the sequence that my lights will go through. Initially, we might just rename this to something more meaningful, light index. The first here is, we start at 2. So let's use that down here. So that means the current light, when I create a new traffic light, will be index 2 of my lights. So that's 0, 1, 2. Initially my lights will be red. My current light is to keep track of what the current light is. Currently I don't actually need to have it as a field variable. I could move this down here. Anyway, when I call the start method, I keep track of what the light previously was. Currently it hasn't really had a previous value. And then for 10 iterations, so I could just keep going, but it sleeps for 2 seconds. Let me just decrease that for when we run the examples. This will be easier. It will then increment the light index, take the modulo 4, which means that my light index, when I assign it over here, it can be 0, 1, 2, 3, and then if it becomes 4, the modulo 4 will make it back to 0. So my light index will just go 0, 1, 2, 3, 0, 1, 2, 3, which is to go through these in a sequence over and over. I keep track of the previous light, so we update that here. Then I update my current light, and then I print out the current light. So if I wanted this to be a subject, down here, when the light has changed, this is where I would notify all my listeners, right? So let us start by implementing the property change subject in my traffic light. We do like this: implements property change subject, and I can press Alt Enter when I want to implement the methods, and it suggests all these 4 methods, and I just click OK, and they come down here. So the add property change listener is where I want to add a new property change listener to my property change support here, right? So I also need an instance of this class in my traffic light. So let's just create that. I'll have a private property change support. There we go. I just call it support or whatever, and I can just instantiate it in the constructor equals new property change support. And this one, you will see if I press Control P, I have the arguments for the constructor, and it is the source. So what is the subject source? And that's my traffic light, so I just give it this. There we go. So I have this in place. I have my association to the property change support, and I can now use the functionality in here, and that's what we're going to do down here. So this one takes a name, and if name, if the name is empty, event name is null, or the event name is an empty string, then I don't want to add it as a, I don't want to listen to event names that are called null or nothing. So then I just will skip that for now, come back to it in a second. Otherwise, that means I actually have a meaningful event name. I want to say to my support, come on, add property change listener. And again, you can see, can I drag this? You can see that I have, I can add it with a name, or the other one, it will just take a listener. And so I need to use that one. It will take a event name and a listener. There we go. Otherwise, I will just call the add property change listener with the listener, like this. So that's this method here. And this method here will use the other method on the support. Here we want to add listener, right? This one, and we'll just add the listener. So if I want to listen a specific name, I add it to the support so that it will listen for this specific name. If I just want to listen for anything, then I add it to the support without an event name, which means that it will listen for anything. And I will do the something similar for the remove. Here it's just remove property change listener, and this one is also remove, and I copy that down here without. Okay, so I can remove a listener now, and I can remove it by event name. So a specific listener, a specific car, will no longer react to this specific name, or I can just remove it so it won't react to anything. That's the idea of the second one. So now my traffic light has the functionality of a subject. I just need one final step, which is to actually notify my listeners. So whenever the light's changed here, I go support, fire property change, and I can give it a few different values. I can give it a property name. We can call it light changed. I can give it the old value, which I am keeping track of in previous, and I can give it the new value, which is the current light. All right, so this is actually all I need for my subject. The support class now handles most of the functionality. I just needed to implement these 4 methods, and because we're doing it with an interface, then whenever I have a subject, I do need to implement these methods, so there will be some copy paste between them, and we cannot really avoid that. But my subject is in place, and I need to go and create our first car. So the first one we will try to stick to the diagram strictly. So I will create a car and it will implement the interface here. Let me create a car 1. All right. I need a constructor. No, I need an ID so I can keep track of the cars, or name perhaps. Private string name car 1. That's probably okay. I need a constructor. Oh, public car 1 like this. I don't think I need any arguments for now, and it's an empty constructor, so I could actually leave it out. Let's just I have it here. Maybe I need it. And then I need to make this into a listener so that it can listen for the changes in the traffic light, and I do that by implementing the property change listener interface. So let's go here, implement property change listener. Right, you can see it's in Java Beans, so that's the one already existing. All right, it's complaining that I need to implement the abstract methods, and I can just alt enter again. It will suggest here, and yes, I want to implement this one. So the idea is that whenever something changes in the traffic light, if my listener is actually subscribed to it, then this method here will be called and I get a property change event. So let's see the event here. We can get the new value. I can get the property name, so that's the event name, and I can get the old value. That's something here which I don't know. I can also get the source, which is the traffic light itself. So there's a bit of information that's sent along this update here, this notification. I will start with the old value, and that is I know that I am sending strings, right? Previous is a string, current light is a string, so I can just cast it here, string, like that, and let's call it, that's probably fine. I can also get the new value. Again, I cast it, get new value, Control Alt V to autocomplete the left side here, the assignment side. Okay, so now I want to react to the change in light here, and if the light is green, what is it that I am actually sending? I'm sending, and those are all capital, right? So if the light is green, then I want to go new value equals green, like that. Then I want the car to drive, and we just print out car 1. So I'm just hard coding it. I'll just remove that, I don't need it. Car 1 drives. Let's just do that. Else if new value equals yellow, all capital letters, yellow. Okay, here I need to do something because the yellow can either be, it can change from yellow to either from green or from red. So I will just steal this. I think you saw it in the exercise, so there's no need for me to spend too much time on typing all that out. We just do this here. Okay, so if the new value is yellow and the old value, just use that one, I have it stored already, is red, then we turn engine on. So we go from red to yellow, and then we are about to hit green. Otherwise, if we go from green to yellow, that means we need to slow down. So finally, the change to red. If the new value equals red, then the car stops. So this is my functionality. My car is now a listener, and this is what happens. And IntelliJ thinks I should swap it for a switch statement. Let's see what happens. Yeah, I don't know. That's also fine, I guess. We'll just keep it like this. Okay, so I have my traffic light. It can change the lights, and whenever something changes, we fire the property change. And my car here can then react to this. So I just need to subscribe my car. Well, in my run traffic light example, I have a traffic light created. I also can create a car one, new car, and we need to add this, add property change listener. And I can either do it so that I just listen to anything, or I can do it so that I listen to something specific. We'll just do anything. Okay, and you saw here that the argument is a property change listener, and I'm giving it a car, but because my car is implementing the property change listener, that means my car is actually a property change listener, and that means that this is okay. Java accepts it. So if I were to run this, let's give it a try. Run traffic light. I would assume that my car prints something out. Right. We also need to start the traffic light. Minor detail. Let's give it another go. See what happens. And we just need to compile everything again. Hopefully the second time it will be slightly faster. There we go. Okay, so light is yellow, car turns our engine on, light is green, car drives, light is yellow, slow down, red, the car stops. So this seems to be okay. My traffic light changes all kinds of stuff and my cars react to it. Okay, so, and there we stopped. So next step is to change my car a little bit. I will just, so the behavior will be the same, but the implementation of it will look slightly different. So instead of having my car extending the property change listener, I'm going to say something different. Public car2, it will now know about a property change subject so that it can subscribe itself to it. And then I will steal the method here. Right, so I want the behavior to be the same. So instead of implementing this up here, I say that I want to create what we call an anonymous implementation of the interface. So property change listener. Now usually you cannot create new instances of property change listeners because it's abstract. So if I try to create a new one, it will actually tell me to make an implementation of the method here. And this is then what we call an anonymous implementation, because it's not implemented by any class. So I just have an instance of a property change listener like this. And in here, I can actually call the property change and give it the event. So now I have a listener. It's not actually the car itself, but I have an anonymous listener, and whenever it reacts to the traffic light, it will call the method down here. So I just need to call this car2, 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 and then we say subject property change listener, and we add the listener. Right. So the functionality will in the end. Oh, it's calling itself. Ah, that's okay. So let me just rename this one here. React to change. And I put that up here. Okay, otherwise I was making a recursive call to itself and my program would crash. So I want to actually call this method instead. So whenever the traffic light notifies about an event, I have added this listener as a listener to my subject. And this method will then be called, which will call this method down here. So this functionality here is executed. And let us give it another go. Traffic light. So let's just try that. Car2, new car2, and this one takes a subject. So that's the traffic light. Now I should be using the actual traffic light in the same package. And let's see, my car 2 turns the engine on. So they both react in the same way. I just have slightly different implementations. Right? I can either make the car implement the property change listener itself, or I can make an anonymous implementation down here. Now the next step, which I wanted to show you, is just using a lambda expression instead. So I will just create a car 3 by duplicating this one. No duplicate, copy paste. We call it car 3. So the functionality will again be the same. I just want you to see what we can do differently. I can alt enter on this one and it can replace with a lambda expression. So this is just even more shorthand. It's exactly the same. So let me just take this here. Like that. So this here is the argument and it's given to that method. So there's some similarity, the argument here, the method that we call, the method that we call. So the lambda expression is just a super shorthand version of all this here. Right? So I can remove that, and that's now what we're using. It's still an anonymous implementation of the property change listener. It's now expressed as a lambda expression. And instead of actually defining it here, I can just put it down here. So this is what I suggest that you normally do. Well, that's up to you actually, but this is what I normally do. This is just a very shorthand notation of it. And then IntelliJ explains that you can actually replace the lambda method with a method reference. So alt enter, and it will just look like this. And the method here is a reference to that one, and it's implicit that there now is this argument. We cannot really see it up here, but it is there. So it's just again shorthand for lambda, which is a shorthand for an anonymous implementation. So let's try and add a third car that happens in my traffic light. Car 3, new car 3, traffic light, so it can add itself, and we run everything again. And now they all, oh, I forgot to rename this one. Right, but they all react similarly, so the functionality remains the same. It just looks slightly different here. Now the last step is to use the event names. Right, I can add a listener so that I just react to anything, but I can also listen to specific events. So let us create a third car, fourth car, car 4. And this is where the lambda expression gets interesting. So let's say car 4, and it needs a property change subject. And instead of, well, I will start by copying this, but I want to actually react to different things. So instead of calling it react to change, no, I'll just remove that. I have it somewhere else. I want to react to specific events, and I have the 3 events that the light turns green, the light turns yellow, and the light turns red. So let's say public void react to red, and I also want to react to yellow, and finally I want to react to green, and I might as well give it a property change event. like this. All right, so that's the argument for all three. And here we go subject property change listener, and I give it the event name, so let's just call it green, and a specific listener. So I can, just like I did before, I can now react to a method. So whenever the event with name green is fired, then my react to green method will be called. We do the same thing for yellow, react to yellow, and we do the same thing for the red and react to red. I then need to put some functionality in here. So react to green, we just print out the car drives. I don't need to check whether it's, you know, green or not. React to red just means that we want to stop. And then react to yellow, I just copy that part and do like that. Right, so my functionality is split out, and instead of just having one method that reacts to everything, where I have to check is it one thing, or is it the other event, or is it the third event, or is it the fourth, or whatever, then I can split it out into specific methods, so I know exactly what happens. Okay, the red event was fired, okay, I need to go to this method, and then I can see it's actually here, instead of if something goes wrong, for example, then I need to check which if statement do I actually go into, and there's more if statements, and it can be a bit more difficult to figure out what behavior we actually have compared to what we intended if we have too many if statements, compared to if I just have the methods here that react to specific events. So what I'm missing here, well, this one is not even using the event, it's only the yellow, so I could actually, well, I cannot remove it because this is implicitly. Oh, right. They must match in method signature. But the thing that I'm missing now is to make sure that the traffic light is actually firing these events here. So I'm firing the light changed event, which I'm not really using, and then I'm just giving it the name, and then I'm using the event in total, but I'm not using that the event is called light changed. But we want to fire property change, and the name, we call it current light. Then I give it the old one, that's the previous, and the current one, that's the current light. So I fire an event called whatever the current light is. And that means if the light changes to green, then I'm listening for green, and I react to green using that method. And then we print out what happens when the car 4 reacts to green. So I think everything is in place, and we just need to modify the last part here. Car 4 is equal to new car 4 with a traffic light, like that. And we try and run everything. All right, here we go. So I get a bunch of printouts. Let's just pause it here. So you can see my car 4, it reacts as it's supposed to do. Now I also get duplicates. Car 1, 2, 3 reacts, and then car 1, 2, 3 reacts again. And that's because my cars 1, 2, and 3, they do not react to a specific light event. They just react to everything. And my traffic light, here we go, it fires 2 events. So cars 1, 2, and 3 react to both of these. I could say that car 1, run traffic light, car 1 is added down here, and that should only react to light changed, like that. Then we will only see one version of the, one printout for the car 1. See? It's only printed out once for the car. We can do the same thing for car 2. I also just want to react to the there we go, light changed event. Right, so I have some control over what kind of events I really want to listen to. Is it every event or is it just some events? And I also have some control over car 4, how I react to the different events. Now I would suggest that you split it out into these methods, but that's entirely up to you. This is just my preference. I find it easier to do it like that compared to having a large method here that must then figure out what is it actually and then check if else, if else, if else. When you do your semester project, if you do it like this, then I would expect that your method here would get quite big. That could complicate things. So this is I guess my suggestion. This is where we end up. We have implemented the diagram in various ways, even though the diagram is still valid for all of them. The implementation part here is just getting more and more implicit. Only the first car actually had the specific implementation, and then the other cars had a slightly more, I guess, a dependency rather than an implementation instead. So we're going to end the video here. Thank you for watching.